Hi, today we're going to be talking about dividing with exponents. And before we start that, it's really helpful to recall that when you have a fraction where the numerator and the denominator are identical, that simplifies down to 1. 2 over 2 is equivalent to 1. 2 divided by 2 is 1. Negative 5 over negative 5, also equivalent to 1. And even with variables, if you have the same variable in the numerator and the same variable in the denominator, they have identical exponents. In this case, they're those invisible ones that we don't bother to write. N over n also equals 1. This will be really helpful as we divide with exponents. Today, it'll also be helpful to recall how to simplify fractions. So remember, you're looking for something that is divisible with both of these numbers. So these ones both end in 5. That's a nice hint that they're divisible by 5. So if we divide our numerator by 5 and our denominator by 5, we're really only dividing by 1 in the form of 5 over 5. When you divide anything by 1, it doesn't change the value, it just changes its form. So instead of 15 over 35, we could also say 3 over 7. 15 divided by 5 is 3, 35 divided by 5 is 7. These are equivalent fractions. We only divided by 1. We did not change the value. Let's look at a couple more just to remind you of how to do this. Okay, so now we have 22 over 26. Nice to notice that these are both even numbers. Even numbers are divisible by 2. So let's go ahead and divide each of these by 2 and see what happens. Divide the numerator by 2, divide the denominator by 2. We're only dividing by 1 in the form of 2 over 2. We're not changing the value, just changing its form. 22 divided by 2, 11. 26 divided by 2, 13. All right, one more. 24 over 42. I see right away they're both even. There might be something bigger that I could divide them both by, but there's nothing wrong with starting with just something small that you see right away, because you can keep dividing if you need to. So I'm going to divide by 2 since these are both even. I'm dividing my numerator by 2 and my denominator by 2. So I'm really dividing by 1 in the form of 2 over 2. 24 divided by 2 is 12. 42 divided by 2, 21. You might notice 12 and 21 are both divisible by 3. So we can continue to simplify. We need to divide the numerator by 3 and the denominator by 3. We're only dividing by 1 in the form of 3 over 3. So we're not changing the value, we're just changing the form. So 24 over 42 is equivalent to 12 over 21, which is also equivalent to 4 over 7. So if you simplify and they still have something in common, you need to continue simplifying until it's in simplest form. Hopefully that helps. Let's start dividing with exponents now. Okay, first example. We have 7 to the 6th power over 7 to the 4th power. We're going to simplify this and we're going to write our answer using exponents. We aren't going to find the actual value of this. We're not evaluating, we're just going to simplify. So the first thing to remember is, what does 7 to the 6th power represent and what does 7 to the 4th power represent? Let's write it out. Okay, so now in the numerator of our fraction, we have 7 being multiplied by itself 6 times. That comes from this right here. 7 to the 4th power means 7 times itself 4 times, like we have right here. Now, to simplify, notice that we have a lot of 7 over 7s. We have 4 sets of 7 over 7. And remember, when you have a fraction where the numerator and the denominator are equivalent, 7 over 7 equals 1. So we're going to simplify all of these down to 1. And it is important to remember that they equal 1. That will show up later. It'll be really helpful later. even though it really doesn't impact this answer because we have 1 times 1 times 1 times 1 doesn't equal 4, it equals 1. And then we have times 7 times 7. So these ones really aren't necessary for now, but I want to remind you they're there because later you will need those. So what we have left in our denominator, these are also ones. We have 7 to the second power over 1, because this all equals 1. So we can just write it as 7 to the second power. We don't need to write the over 1. That's just extra. So 7 to the second power is what we end up with. So looking at the original problem and our result, you might notice that there is a shortcut. Let's look at another one to see if it holds true. Okay, we have another fraction, and fractions are just another form of division, so that's why this is called dividing with exponents. So we have x to the third times y to the fourth being divided by or over x to the fifth times y. So let's write it out the long way and see what happens. Okay, in the numerator, x to the third is x times x times x. Y to the fourth, y times y times y times y. In our denominator, x to the fifth, there they are, and we just have one y tagging along. So now let's simplify. Let's look for ones. We have x over x, that equals 1. We have another x over x equals 1, and one more, x over x equals 1. We don't have any more x's in our numerator to cancel these out with, but we do have a y, and we have 4 y's up top. So let's go ahead and cancel these out to equal 1. Y over y also equals 1. So now we look at what's left. I have 3 y's in the numerator. That becomes y to the third power. Y times y times y, y to the third. In our denominator, x times x, x to the second power. So let's compare our result with our original problem, focusing on one variable at a time. That just makes it easier. In our numerator, we have 3 x's. In our denominator, we have 5, all being multiplied together. These 3 x's are going to pair up with 3 of these x's and cancel out to become 1's, like they did here, which leaves 2 x's in the denominator. So the difference between these two is 2. So where do we have more? In the denominator, so that's where they stay. Let's look at the y's. We have y to the fourth, which we wrote out over there, and y to the first, which we wrote right here. This one y pairs up with one of these y's, and it cancels out to equal 1, leaving 3 y's in the numerator. So the difference between these two is 3. And where are there more? In the numerator. So that's where they stay. So we're looking at the difference between the exponents and where are there more, and that's where they stay for now. Later we'll learn more of how we could also write this, but for now, that's where they stay. All right, example 3. Now we're mixing in some numbers. In our numerator, we have 4m squared n, and in the denominator, we have 12mn to the fourth. Remember, this power of 2 is next to the m, and it only affects the m. It is not next to the 4, does not affect the 4. This does not become 16. N is also not affected by that power. Same thing with this power of 4. It is only next to the n. It's only affecting the n. We do not let it affect the m, and it definitely does not affect the 12. So just remember that. Let's go ahead and write this out the long way. Okay, so in the numerator, we have 4 times m times n, and in the denominator, 12 times m times 4 n's all in a string. We are going to do what we've been doing, which is to focus on each piece separately. Let's start with the numbers. 4 over 12. 4 over 12 is a fraction. 4/12, these are both divisible by 4. Divide by 4 here, divide by 4 here. We are only dividing by 1 in the form of 4 over 4, so we're not changing this value, we're just simplifying it. 4 divided by 4 is 1, 12 divided by 4 is 3. 4/12 simplifies down to 1/3. So I'm going to go ahead and put a 3 in the denominator, and we don't have to write the 1 in the numerator, but let's put it there for now. Okay, and I'm going to erase this. That was just kind of my side work. Let's look for other ones that we can simplify with. The m's. We have an m in the numerator and an m in the denominator. We can pair those up, and that simplifies down to 1. M over m is 1. We have 1 m left in the numerator, but none down here, so we cannot simplify that any farther. That means we still have an m in the numerator, so I'm going to write that up here. Our n's, we have 1 in the numerator and 4 in the denominator. We can take this one and pair it up with one of these. N over n equals 1. That leaves us with 3 n's in the denominator, n to the 3rd power. So when we're all done, you could leave this as your answer. It's not wrong, but if you're looking for it on a multiple choice test, this 1 would not be there. It would just be written as m over 3n to the 3rd. Okay, so let's look at the original compared to our final result. Looking at it one piece at a time. Numbers first. 4 over 12 simplifies down to 1/3. The 3 is in the denominator. The 1 isn't written because we don't need it. M to the 2nd over m to the 1st. The difference between these is 1. Where are there more m's? On top. This 1m cancels out one of these m's, leaving us with m to the 1st in the numerator. And we don't write that 1st power because it's extra. We don't need to. We have n to the 1st in the numerator and n to the 4th in the denominator. This 1n cancels out one of these, leaving 3 in the denominator, n to the 3rd power. Okay, last example. We have r to the 3rd power times t in our numerator and 4r to the 3rd power t to the 5th power in our denominator. This power of 3 only affects the r, doesn't do anything to the t. This power of 3 only affects the r, does not affect the 4. This power of 5 only affects the t. Exponents only affect what they're next to. Let's write it out the long way and see what happens. Okay, there's a lot of r's and t's here. R to the 3rd, there it is. T to the 1st, right there. We just don't write the 1st power. 4 times r to the 3rd, t to the 5th. We are looking for things we can simplify. The 4 doesn't have anything that it can simplify with. It's going to stay in our denominator. The r's, I have some r's I can pair up. Remember, r over r equals 1. And here's where writing that 1 is going to be super helpful. We have 3 r's over r's. They all equal 1. T's. This t can be paired up with this t. T over t also equals 1. And what we have left is 1 times 1 times 1 times 1, which is 1. If you forget that this equals 1 and you cancel everything out, it's not 0 that goes in the denominator. It's not that it's not 0 that goes in the numerator. It doesn't mean that there's no longer a numerator and it just is what's left on the bottom without it being a fraction anymore. No, we have to hold that numerator with a 1. 1 times 1 times 1 times 1 is 1. In the denominator, we have our 4. And we have t to the 4th power. So when we're all done, I'm just going to write this a little bit more centered. We have 1 in the numerator and 4t to the 4th in the denominator. So looking at the original and the result, You can see r to the third over r to the third right here. This could cancel out to equal 1. T to the first over t to the fifth. This t to the first is going to cancel out one of these, leaving t to the fourth in the denominator, and that 4 doesn't have anything it can simplify with, so it's just going to stay right there. So hopefully this was helpful. Good luck with your assignment.